Okay, so sorry I started the video too soon. So we're going to do implicit differentiation. So if the derivative is y, you just do a dy dx. So you do the power rule, and then dy dx, and then this is the product rule. Okay, so now what do we do now?
Move all the dy dx to one side.
Very good. I'll move all the dy dx to one side. Anything that doesn't have a dy dx stays on the other side. And we're solving this for dy over dx. So we're going to factor it out. And then we're going to divide by what's in the parentheses. All right, and we have shown that it is what they said it was, which is good. Okay, part B. We're going to write an equation for the line tangent to the curve at the point 0, square root of 3. Now we have practiced a lot of these lately. They have them in all different types of FRQ, so that's good. There will 100% be one on your test. It might be in this one, it might be in the differential equation, we just don't know. But anytime we're doing a tangent line, we need a pot and we need a SOT, and they just give us the pots. So that's good. All right, to find the SOT, we're going to plug that point in to our differential equation. So we're doing 0 for x and square root of 3 for y. Alright, so what is the cosine of 0? Just 1. So that numerator is going to be square root of 3 times 1, or just square root of 3. What about the sine of 0? It's 0. So what's our SOT? Oh, I messed up. Let me fix that. Alright, what's our SOT? Yeah, it wasn't a trick question.
Is this okay? I always get confused. When do we do like the equation for the tangent?
Right now.
Right now we're about to run it. Okay.
So when it asks you to write an equation for the tangent line, you do. Sometimes it'll just say what's the slope of the tangent line. If they do that, then you're done. But if it asks you to write an equation of the tangent line, you have one more step, and it's going to be y equals the y coordinate of the pot plus the SOT times x minus the x coordinate of the pot. And if you don't put minus 0, it's okay. All right, y'all good? Huh? I know. You're gonna. I can't wait to see your test. I know you're gonna have one. You're gonna do so good.
That's the only one I'm like, yeah, I know that.
Okay, so then for C. This is, on these questions, as you go, they start getting a little more challenging. So C and D are typically more difficult. So for C, we know that x is going to be between 0 and pi, and y is greater than 0. We want to find the coordinates of the point where the tangent line of the curve is horizontal. So what do we know about the slope when there is a horizontal tangent line? It is 0. So we need to find when dy dx equals 0. Is that going to come from where the numerator is 0 or the denominator? The numerator. What would happen if the denominator is 0? And what kind of line is undefined? Vertical. So it's possible a question like this, say the coordinates of the tangent line, a tangent to the curve is vertical, and then we would focus on the denominator. You might see one like that in a minute. All right, so this is multiplication. So we're multiplying y times the cosine of x. So for that to equal 0, either y needs to equal 0 or the cosine of x needs to equal 0. Is y equals 0 in the range of this problem? No. So we just don't worry about that guy because it tells us that y has to be greater than 0. All right, and then we need an angle that's between 0 and pi that has a cosine that is equal to 0. Good job. Are we done? Okay, it says find the coordinates of the point. So I do know that the x is pi over 2. So how am I going to find the y? Which one? Plug into the original. Man, you guys are going to kill this test. All right, so there's several y's in the original, but there is only one x. All right, what is the sine of pi over 2, 1? So that's going to be 1y or just y. And then we're going to get everything on one side, and we're not going to freak out because there is a 2 in front of the y squared. So we can do this, right? He's not even paying attention. All right, so to get 2y squared, we have to use what and what? There we go. All right, so we're either going to use 1 and 6 or 2 and 3. So I'm going to get negative 1. I feel silly walking you through factoring, but I feel like you guys might not have got enough factoring last year. And that's my fault. All right, what do y'all think?
2 plus 2 plus 3.
Yes, so that's going to be negative 4 plus 3 is going to be negative 1.
Wait, is it 2 plus 2 minus 3 or plus 3 minus 2?
It's plus 3 minus 2.
Because
no,
we're trying to get a negative 1.
yes. That's going to be 4, and that's going to be 3. So that subtracts to give you the 1, the negative 1. Okay, so we do originally get 2 y's. However, it tells us, again, that y has to be greater than 0, so that is not the y. So our final coordinate is pi over 2, 2. That's okay? A lot of algebra on that one. All right, D. D has a lot of calculus. So we're going to determine if f has a relative minimum or relative maximum or neither at that point. So that point has a horizontal tangent line, which means it could be a relative max, it could be a relative min. It could be a situation like this, where it's neither a relative max nor a relative min. So when I started doing this problem, I initially thought, okay, let's do a sign chart. So let's do a number line and check on both sides of pi over 2. The problem is that you need to know the x and the y to check, and find that would be a nightmare. Like, you would have to do a whole lot of things that might not even be possible to factor. This is not a calculator test. So is there another way to figure out relative max and min if you have a critical point? The second derivative test. Second derivative test. Yes. So we get to find the second derivative implicitly. Now, there's a good chance that if you were taking this in 2021, you might have tried to do the number line, and so it takes time, and time is something you don't have a lot of, but it's okay. So let's find the second derivative. It's super fun. We get to practice a whole lot of calculus to do it. So the reason it's super fun is because the first derivative is a quotient. So we're going to do the quotient rule. Inside the quotient rule, we're also going to have to do the product rule. So yeah, it's going to be great. Which we kind of have already done. We kind of have already done the product rule. So we'll see. Let's see what we can do. All right, so what's the first part of the quotient rule? Low. So we're just going to bring up low. And then we're going to do d high.
Which will be that, like, y cosine of x plus sine of x. What is?
Did I mess up on that one? So it's y, and then what's the derivative of cosine?
Negative sign.
Yeah, did we write that?
That was what I was asking about.
Okay.
Like if we did negative sign?
Because I was like, I was asking which one was
Oh.
sine and cosine. like,
My
which
bad.
one-
We haven't done this yet.
Yeah.
I'm sorry.
Before we
I
just-
lost. We were finding the derivative of this one.
Okay.
Now we're finding the derivative of that one. Sorry. You're right. It is negative sign here. I was just confused. We do have to do this. We haven't done it yet. All right. So di. So y times the derivative of sine plus, sorry, y times the derivative of cosine plus cosine times the derivative of y, which is dy dx. Alright, so that's low d high minus high, and then d low. Alright, so 4y, what's the derivative of 4y?
4 dy.
Yes, ma'am. And then what is the derivative of sine?
Negative cosine.
Cosine. Now we do have a minus because there originally was a minus. All right, all over low squared. Double checking my parentheses. Now what we want to know is if at that point where I have this critical point where the derivative is 0, if I get a positive or a negative.
Sorry.
You're fine. So we're going to plug in that point. All right, so in for y, I'm going to put in 2. In for x, I'm going to put in pi over 2. Okay, and now I have a question for you guys when you get caught up. What about dy dx? What's dy dx at this point? 0. Good job, Kina. You're killing it today. That's going to be 0. Now, if we didn't have a point we were plugging in, like if we were just finishing the derivative, the second derivative, what would we put in for dy dx? I'll come back to that 0 in just a second.
If we were just doing the second.
Yeah, if we were finishing this problem without a point, what would we put in for dy dx?
We would put the y.
Yes, ma'am. We would put this in. And then it would get kind of crazy. But here we are doing it at a point. And so all of this is what's happening at this point. The whole reason why we have that point is because it was where dy dx was 0. So when we plug this in, we already know all of our dy dx's are going to be 0. All right, so then minus 2 cosine pi over 2 times 4. Now that's going to be 0. Minus cosine is 0. Hopefully you guys have more room than I do.
Cosine of pi over 2.
Oh, sorry, thank you. Cosine of pi over 2. Now we don't have to know exactly what this equals. So like for example, this denominator, no matter what I get inside here and I square it, am I going to get a positive or negative? Positive. That's all I'm going to put down here. I know that's a positive. Numerator, we're going to have to figure out some stuff. So I do know that 4 times 2 is 8. And I do know what the sine of pi over 2 is. Do y'all know? 1. Right? And then this one is the negative sine of pi over 2, so that's going to be negative 1. Okay? It doesn't really matter at this point what the cosine of pi over 2 is. It is 0, but I'm multiplying that by 0, so this for sure is going to be 0 added. Right, so this is another situation where like we're doing a bunch of stuff here, but in the end I'm multiplying by 0, so this is going to be 0. What about the cosine of pi over 2? Also 0. Okay, so if I take, well, let's just do it. That's fine. So that's going to be 7 times negative 2 plus 0 minus 0 over a positive. Is that going to give me a positive or a negative? That's going to give me a negative. Now, it took up all my room doing this work, so we don't have a ton of room to give our justification. So whenever it says justify, you have to, it's a formal, using a rule or a test or a theorem. So this has to be super wordy, and you do have to mention what we're using, which is the second derivative test. So what do you guys think? Is it going to be a relative max or a relative min if the second derivative was negative?
Second, it's max.
Yes.
I just remember the opposite.
From what you think? Well, let me tell you why. So the second derivative tells you concavity.
That's what I thought.
So if the concavity is negative, it's concave down. And a critical number concave down is a relative max. Very good. So the relative maximum at pi over 2, 2, because the first derivative, dy dx of pi over 2, 2 is 0. And the second derivative, oh, thank you. Of pi over 2, 2 is less than 0. Maybe you don't want to use those symbols. You can write out the words if you have room. All right, so that's implicit differentiation. I bet you'll see it somewhere. It might not have its own question, but I feel like you're going to see it.